Hello, welcome to another exciting edition of Algebra class. I'm your host, Mr. Spence, and I will help you along with today's stuff. Right. Lesson 22. Different kinds of graphs. What's the title? Analyzing and comparing statistical graphs. All right. This is about reading pictures. That's what we're talking about today. Reading pictures. Now, statistics is a fairly new area of math, and analyzing statistics or analyzing data is a pretty big deal these days. Even in sports, watching baseball is definitely different than it was watching baseball when I was a kid. There are a lot more things that they call metrics that they are watching and measuring, and can know a lot more about the habits and skills and whatever of different players. So it used to be just this thing called slugging percentage, but now they've got percentages in the strike zone, and they've got where typically this person hits the ball, and you can do the same thing on a pitcher. They're always doing these serious pitch counts on them, and all kinds of crazy stuff. Same thing with soccer or football. With soccer, they're measuring where people are on the pitch, and how much time they spend, how fast they go, how far they've run, left foot, right foot, where they take shots from, all that kind of stuff. So gathering statistics is getting more and more prevalent in our society, but then the interpretation of those statistics is very important because we make financial decisions, we make other kinds of decisions based on the information that we're given. Now, the information can be displayed in lots of different ways in order to, I would say, tell a story. And as um, Josh Montai has said before, numbers don't lie, but liars use numbers. So it is a skill in life to know how to read a graph and know what it's trying to say, to spot things that are inconsistent or wrong with them. But there are different kinds of graphs that you can use with different kinds of information. And in math, there are two general forms of data collection. There's one variable statistics, and there's two variable statistics. One variable statistic is just like going around and asking everybody what's their favorite flavor of ice cream or their favorite number. Just going to gather one type of bit of information. What's your favorite kind of animal? What's your favorite meat? What's your favorite color? What's your favorite, I don't know, book? Okay, what's your favorite body part? I don't know. That can all be collected and then categorized and then put into certain kinds of graphs like a bar graph. All you need is a certain amount of information. And then you're just comparing apples with apples. Or a circle graph, for that matter, can compare a one variable statistic type of thing. What else? Here's the things that they got in our lesson. Bar graphs and histograms. Histograms is a special kind of bar graph we'll talk about later in the year. Double bar graphs, you're comparing just two sets of the same kind of information, but it's not really two variables. Stem and leaf plots is a one variable statistic. We will use that as we talk about later on. We'll talk about home runs, comparisons between a couple of different guys, either Babe Ruth and Marge Maris, or Mark McGwire and Sammy Sosa. We'll be using stem and leaf plots to compare their home runs over their career. There's also some graphs later that will be called box and whisker plots. That's one variable statistics. But if you then want to compare how one thing changes in respect to something else, like as we were discussing with slope, you're going to use a two-variable statistic type of thing, like a line graph, where you're seeing one thing like time changing and then another factor changing as well. In your book, they have some line graphs and double line graphs on page 129, and that one shows time on the x-axis, and it shows the number of sandwich shops. You can never have too many sandwich shops, can you? Yes. On the vertical axis. So you'll see something changing over time as time changes. You have two things that are changing at the same time. And when you use two variable statistics, you're typically trying to find some type of what they call correlation. Is there a rule that helps me see how one thing changes as the other thing changes? And there is one of the first laws in statistics is that correlation does not mean causation. That if one thing's going up and another thing's going up, it doesn't necessarily mean that one thing is causing the other thing. It's just that there is some type of correlation between the two of them, either positive type of correlation or negative type of correlation, or strong or weak correlation between those two things. If you don't know what the word correlation means, get a dictionary. For instance, I think I mentioned before that shoe size and reading ability are correlated. So, and that is because kindergartners have small feet, and fourth graders have bigger feet, and 10th graders have even bigger feet than that. It doesn't mean that because your feet grow that you'll be a better reader, or if you become a better reader that your feet will grow. Doesn't mean that. There's something else going on there. It has to do with maturity and growth and all those kinds of things. So let's just take a look at what these things look like. And then you see these kinds of things all the time on SAT tests and standardized testing, where you have to be able to read graphs. You have to be able to notice a few things about them in order to interpret it right, and then even to make predictions. So I'm just going to draw some pictures and talk briefly about each one of those, but I'm not going to go into too much detail because you've got a lot of examples with specific questions in the book, and I can't really show you too many of those except by maybe holding something up and saying, look, behold, double bar graph and double line graphs. So it's going to be really hard for you guys to read some of the details there about these things. So let's start with bar graphs. Bar graphs can either go vertically or horizontally, but basically you're going to have, I'll do the first one vertically. You're going to have these separate bars that represent some type of factor. Let's say favorite animal. And over here you're basically going to have a frequency meter. 4.5 people. Maybe we're going to put here duck, llama, and weasel. Okay, it's pretty straightforward. All the bars are the same width. On a regular bar graph, they're separated by a little bit of space. You've got on one side one type of factor, probably labeled, and the other side a frequency that's numbered, so you can see how high the bar is, what that means. Bar graphs can also be done sideways, so you can compare things this way, but that's just changing its orientation. Histograms have no gaps between them, and they have equal intervals. And so a true histogram will look something more like this. This one will be from 0 to 5. This one will be 6 to 10, 11 to 15, 16 to 20. You got equal intervals on this side, and you're still measuring the frequency on this side. So maybe that, and your calculator can do histograms, but that'll come later. Double bar graphs will just have two different colors, and you're comparing maybe two different people or two different sets. So maybe here, if we were doing a double bar graph we might have the dark one representing what we got out of the first grade class, and the light ones being what we get out of the second grade class. But still, we're just measuring one thing for each group, still one variable statistic. So you're looking for the details kind of on this side, what exactly is being measured, and then how many are in each. And then as you compare, you can start saying things like this is increasing or this is decreasing, or you can say this compared to this one, look for differences, all that kind of stuff. What else? Stem and leaf plots are going to take a list of numbers. And they're going to put them in a different format. They're going to put things in what's called, well, you got a stem like on a tree and a leaf which comes at the end. And the stem will represent the tens place and the leaf will represent the ones place. So all these numbers get translated into something like this. 12 becomes this, 27 becomes this, 32 becomes this, 37 gets put right here. 37. 7 represents its own data point. 43, 41, 40, 40, and another 12. And that can show you things in groups. How many 10s, how many 20s, how many 30s, how many 40s. You can order them if you want to. And it kind of turns into a bar graph sideways. You can kind of see here that this one's got 2 members. This one only has 1. This has 2. And this one has 4. And you can kind of group them together like that and look for patterns. Stem and leaf plots will come up again in lesson 62. We'll formally introduce those and work with them. You'll be creating them for yourself. Line and double line graphs typically have time on the x-axis, and then they'll have maybe dots. Maybe it's like year 2000 and 2001 and 2002 and 2003. Maybe it's the stock market, so there's like profit over here. And then they could throw in another one there too and just give you a different symbol, and you can compare the growth or not growth of 2 different kinds of things. But again, you're looking for certain things. You're looking for what's on the x-axis, how's that increasing? Is the other thing increasing, decreasing? You can compare 2 sets of data then, how they increase or decrease. But the first thing I think you need to do is just do a little bit of observing and read all the details first before you start making any types of conclusions. So there's both interpreting and comparing types of problems here in the book for you. The last one, the circle graph. I think you know about those. Sometimes they call them a pie chart. Each section takes up a certain percentage of the whole that should be listed, and the whole thing should add up to 100%. Sometimes then they'll leave out one bit of detail, and you can fill in the gaps by doing a little bit of math. They're going to show that to you in example 5, so you should try that out. But for the most part, it's looking at the representation and gleaning the information that you need from that. So happy picture reading, and here comes Mr. McAndrews.